objective length, the final image is at the infinity. That means microscope, it works under two adjustments, normal and non-normal. Under normal adjustment, in a microscope, final image is at the near point. In a microscope, non-normal adjustment, final image is at the infinity. Therefore, this microscope is working under non-normal adjustment. That means final image is at the infinity. Right, okay. Now how would we draw the ray diagram? Okay. Now you know that in this case, see, here is our objective lens located. Objective lens. And its focal length is FO is equal to 10 millimeters. Right. Now, normally we keep, now, always remember in microscopes, our object should be placed between F and 2F. F is 10 millimeter, then 2F is 20 millimeter. Normally, we keep our object between 10 millimeter to 20 millimeter range. That's why they kept the object in 12 millimeters from the objective lens. Now, here is our focal FO. Now, our object is somewhere here. This is our object, simple capital O. Then object distance is 12 millimeter. Try to understand everything. Now object distance is 12 millimeter. Right. For this objective lens, this is the object. It produces an image. Where should be that image? Whenever your object is between F0 and 2F, your image should be beyond 2F in the opposite side. You learn everything. Now your image is beyond 2F. So when you calculate and when you find the image distance, definitely image distance should be greater than 2F. Okay, we'll check that. Right. Now I know my object distance is 12 and my focal length is 10 millimeter. Now my target is to find the image distance. Actually, in order to draw the ray diagram, you don't need to draw everything. You don't need to what? Need these values. For your understanding, I'm getting the value. Okay. Now I'm applying lens equation. It's an explanation. Lens equation. 1 over V minus 1 over U is equal to 1 over F. Image distance, that's what I want to find. So therefore, I'm not going to apply sign convention for V, but for the remaining two variables, I'll apply sign convention. Now object distance. Here is our object. Light ray passes to the right. Light ray. But you start measuring your object distance from the lens to the object. That means your object distance direction is to the opposite side. Light ray is moving to the right. Therefore, both are opposite. Therefore, U is plus. It's a convex lens. Focal is minus. I know the values. I can substitute the values. 1 over V is equal to minus 1 over V minus U. U means 1 over 12 equal to minus 1 over focal length is 10 millimeters. Right. I want to find my V. I subject 1 over V. Therefore, I'll bring minus 1 over 12 to the opposite side. 1 over 12 minus 1 over 10. So this simplification, very basic. 120, 10 minus 12. Then I would get that 1 over 1 over v is equal to 10 minus 12 means minus 2 over 120. That means my image distance is equal to minus 60 millimeter. See, it's true. Because what I have argued, I mentioned that when your object is between f0 and 2f, definitely your image should be beyond 2f0. f0 is 10 millimeter. That means 2f0 is 20 millimeter. Therefore, your image should be beyond 20 millimeter. Yeah, image distance is 60 millimeters. It's true. Okay, we don't need these calculations to draw the ray diagrams. Okay, for your understanding, I just mentioned. Right, now what happens? Okay, therefore your image should be somewhere here. Okay, I can decide the location of the image by drawing the ray diagram. So normally we use two standard rays. Whenever light rays starting from the top of the object, as it passed through the center of the lens, its direction does not change. Therefore, then this is the ray. Okay. And another ray starting from the top of the object, and it is parallel to the principal axis. What would happen? Whenever light ray incident on the lens parallel to the principal axis, definitely passes to the focal point. I think you understood.
Yeah.
I'll bring my focal to somewhere here in order to draw the ray diagram. Okay. Then we can see that. Now here is the focal, if not, then an image forms at here. What can you say about the characteristics of that image? Yeah, really light rays are converging to that point. Therefore, definitely at this place, real image should be there. And it's an inverse. Right?
Yes.
So I just consider this image as my I1. Okay. Then what happens? Objective lens is here. I have another lens. What is that lens? Eyepiece. Right, this is my eyepiece. Now we know our final image should be at the infinity. Now you want to think. Our final image should be at the infinity. Now for this eyepiece, I1 is the object. So it should create an final image at the infinity. In order to do so, where should your I1 located? Definitely, your I1 should be on the focal length of eyepiece. Then only it's possible to what? It's possible to what? Create an image at the infinity. Because we know, you learn that whenever object is kept in the focal point, then you would get an image in the infinity. So you learn this. Whenever your object is in the focal point, then final image, then the image is at the infinity. Now in this case also, under non-normal adjustment of a microscope, our final image should be placed at the infinity. Final image will be placed at the infinity when this image, if not for this object, if this is exactly at the focal point of this eyepiece. So therefore, this point should be FE, right? Then I think hereafter, the remaining part is very easy. Now, in order to decide now, right, okay, we came up to here, we understood everything. But the problem is, how do we draw the remaining ray diagram? So we drew until here. But now we don't have any idea how do we draw the remaining part. In order to draw the remaining part of those rays, we are going to use two more additional rays. But remember, when you are using additional rays, you have to draw them in dotted lines because these are our two main important rays. These are our main rays. Therefore, no matter whenever you use more rays, but remember, you should draw all the rays in dotted lines. In order to decide the remaining path and the location of the final image, we have to use two rays, standard rays. We can think now, this is our object. We can think this as our object. It's our lens. We can use our two standard rays. Whenever ray is passing through the center, then it keeps continuously moving without changing its direction. Right? In one ray. I drawn it by using dotted lines. So what is next our standard ray? Whenever light ray is parallel to the principal axis, whenever light ray is parallel to the principal axis, it will pass through the focal point. Yes. Then where should be our final image? When you extend the lines to the backward, when you extend these two rays to the backward, then you can see it never converges. That means your final image is at the infinity. Oh, there is no any converging point you could see. What it says that final image is in the infinity. Final image. Right. Okay, we have decided our final image should be at the infinity. Then how would remaining these two rays will move parallel to these rays? Now this is the basic ray diagram. Okay. It's not difficult. Here what we have done, see, when I was drawing this diagram, I didn't draw two lens at the same time. I just draw this one and we decided normally in all the microscope cases, we keep our object between f0 and 2f0. So I keep my object between there. Then I use two standard rays. One standard ray is a ray passing through the center. Other standard ray is a ray parallel to the principal axis. Then we decided the remaining path. Then here image formed. For this lens, this is the image. Now they clearly mentioned, now the microscope is working under non-normal adjustment. Therefore, final image should be at the infinity. In order to what? Maintain an image at the infinity, definitely this image should be at the focal point of this lens. See how many logics are there, right? Then if you understand these things, nothing to do in this question. See, I hope you understand.
Yes.
Okay. Now deciding the angular magnification. Right. Now, how do we decide the angular magnification? Okay. How do we find the angular magnification? Hmm? Now, they have given object distance, and they have given focal length of objective and focal length of eyepiece is given. Objective is 10 millimeter and focal length of the eyepiece is 20 millimeter. These are given, right? Then what can you say about this distance? What is the this distance? It's exactly equal to 20 millimeters, because if this is the focal point of the eyepiece, then this distance should be 20 millimeters, right? Okay. This is my first image. My second image is at the infinity, so I don't know the parameters and I don't know the characteristic of that image, right? If I consider object height as h and this image height as h1, yes, angular magnification is nothing but, see, angular magnification. Angular magnification is notated by capital M. It is nothing but alpha dash over alpha. And remember one thing, I'll explain alpha dash. Alpha dash means what? Final image. Angle subtended to the eye by the final image. Final image. Understand? We know according to this diagram, our final image is at the infinity. Now our final image is at the infinity. Then therefore, when we use this microscope, we keep our eyes closer to the eyepiece. That's why we call that lens as eyepiece. Therefore, we can think eyepiece is exactly located very closer to the eye. Therefore, now what is alpha? Angle suspended to the eye by the final image. Then this should be our alpha dash. Now here is your eyes. Now object is somewhere here. Angle suspended to your eye by the final image. So this is your alpha dash. What is alpha? Alpha means what? Angle what? Suspended to your eye when object is at the near point. Right. That means what? Now I just bring this object and I keep that object far to the near point. For an example, suppose this is my eye. Now I keep this object at the near point. Now my object is at the near point. Then angle subtended by the object to my eye. This is alpha. The height of the object is h. This angle subtended by the object to the eye. Object. Now we know, remember that these angles are very small angles. Therefore, no matter when you take the angle ratio, alpha dash over alpha O, they are tan ratios. Answer is same. Therefore, we can think that alpha dash over alpha as our tan alpha dash over tan alpha. Now hereafter, we are by using this diagram and geometry, we are getting what? We are writing these in other terms. Tan alpha dash. Tan alpha dash means what? Tan alpha dash. H1. So look at this triangle. When you look at this triangle, When you look at this triangle, I think you can see this triangle. Tan alpha dash, that means H1 over FO, sorry, FE. So we know this distance is FE. So tan alpha dash is equal to H1 over FE. H1 over FE tan alpha. Now tan alpha means what? So look at this diagram. Tan alpha means what? Opposite over adjacent, H over D. H over D. Capital M. That means what? Capital M is equal to H1 over FE H capital D. So I just took the reciprocal. Therefore, H1 over H capital D over FE.
It's shining there. Okay, now can.
H1 over H capital D over FE. It's our capital M. I think you can understand.
Yes.
Now, that means capital M is what? H1 over H D over FE. I know D is 25 centimeter because D is the near point. FE. FE means what? It's also 20 millimeters. 25, 20 millimeters, right? But now, in order to find the angular magnification, if we can find the ratio of H1 to H, problem solved. Now thinking, H1 over H ratio, how can we get that ratio? H1 over H. H1 means image height produced by this lens. For this lens, image is this one, it's H1. H means what? Object height. Can you remember linear magnification of this lens? We know. I keep this as my equation 1 and I'm going to talk about another stuff. Linear magnification of objective lens. Linear magnification of the objective lens. Is equal to what? Image distance over object distance. If not, we can write image height over object height. Now H1 means image height, right? H means object height. H1 is image height. H is object height. Therefore, we can write H1 instead of H1 over H, we can write V over U. V means what? Image distance. Image distance V. We want object distance is 12 millimeter. Right. Now my target is to find this ratio. Yeah, I want to find H1 over H and I realized H1 over H is nothing but V over U. Now my concentration moved to find V over U ratio. I'm going to apply lens equation for objective. Lens equation. Can you hear?
Yeah.
Lens equation. Lens equation. For objective lens. Right. 1 over V minus 1 over U O equals 1 over F. In this particular case, right, I am going to apply sign convention as I mentioned. Now this V is when you measure the V distance from the lens, it is in the direction of the light, therefore V is minus. When you measure U distance, this is U, it is opposite to the direction of the light, therefore it's plus. Normally convex lenses focal is minus. Therefore, minus 1 over V minus 1 over U is equal to minus 1 over F. You can cancel out all the minus terms, then you will get 1 over V, 1 over U, 1 over F. Now my target is I want to generate V over U. I want to generate V over U. I can multiply all the terms by V. If not, I can do another thing. I can multiply all the terms by U. So you just think that instead of multiplying all the terms by V, why I am multiplied all the terms by U? Just think. I am going to multiply all the terms by U. U over U, U over F. Then U to U get cancelled out. Then U over V is equal plus 1 is equal to U over F. Suppose if I multiplied all the terms by V, in here, I would get a V. But I don't know the value of V, right? That's why I decided to multiply all the terms by U, because I know U is what? U means object distance for this lens, it's 12. I know. Therefore, U over V is equal to U over F minus 1. Here F means F naught. Now, by looking at these two equations, equation 1 and equation 2, capital M is equal to what? H1 over H. H1 over H means nothing but V over U. V over U. But here I have found U over V. Okay, we'll simplify this. U over V. We know U is what? It's 12. F naught is what? It's 10. Minus 1. So you would get that U over V is equal to what? 12 over 10 means 1.2 minus 1. 0.2. Then V over U is equal to what? 1 over 0.2. That means 5. V over U is 5. Then H1 over H means V over U D over FV. That means V over U is what? 5. Capital D is 25 centimeter, FV is 20. Then you would get that 25 over 4 as your answer. Did you get this answer?